So let's talk about first order reaction. Let's take an example. N2O5 in gaseous state gives 2NO2 in gaseous state plus 1 by 2 O2 in gaseous state. Let's say H2O2 in gaseous state gives H2O in gaseous state plus 1 by 2 O2 in gaseous state. This is liquid state. Let's see one more example. SO2Cl2 in gaseous state gives SO2 in gaseous state plus Cl2 in gaseous state. These are all the example of first order reaction. Okay, so take a general example. A in gaseous state gives B in gaseous state plus C in gaseous state. So let's say initial concentration. Initial concentration of A is A, B is 0 and C is 0. Okay, and concentration at time t. Concentration at time t. Let's say it is A minus X. Since stoichiometric coefficient is 1, stoichiometric coefficient is B is 1, so it is X and it is X. So this is the first order reaction. Okay, we know the reaction we see is experimentally determined. Okay, so rate of the reaction, how we can write the rate of the reaction? Rate of the reaction we can write here. Rate of the reaction is minus dA by dt equals to dx by dt. Okay, now if we see the differential form of rate of the reaction, okay, differential form of rate of the reaction. If we see the differential form of the rate of the reaction, if we put the value of A, what was the value of A? Minus dA minus X by dt. Okay, that was equals to K into concentration of A. Okay, since it is the first order, if we differentiate this, we will get it dx by dt, that is K into A minus X is the concentration. Okay, now since let's cross multiply this. Okay, so we will get dx by dt. Okay, here we will getting dx by a minus x equals to k dt. Okay, dx by a minus x equals to k dt. It is a minus x is k dt. Now if we see again, if we cross multiply this, okay, if we start integrating that, the concentrate at time, if we differentiate integrate that, we will get minus ln a minus x equals to kt plus c. Ln a minus x equals to kt plus c. Okay, now we know at t equals to 0, x is 0, so minus ln a equals to 0 plus c minus ln a minus x equals to kt minus ln a. Okay, so ln a minus x minus ln a equals to kt. So ln minus of ln a minus x plus ln a equals to kt. So ln a divided by a minus x equals to kt. So this is the integrated equation of first order kinetics, where A is the initial concentration of the reactant. Okay, so if we draw a curve between ln a minus x to time, it will give this type of curve. Okay, which has a negative slope. Okay, so here we will see now what is the value of A. K equals to 1 by t, it is 1 by t, ln A divided by A minus X. Okay, we can also write as K equals to 1 by T ln what is the value of A? It is A naught. What is the value of T? It is A T. So this is the value of K. It is A at a time T. A naught is the initial concentration of A and A T is the concentration of reactant at the time T. Okay. Now we see if we try to calculate alpha. Alpha, which is a dissociation constant. Alpha. We know A is forming B plus C. So it is A minus X, X and X. If we have alpha as a dissociation constant, we might be writing it as a 1 minus alpha, A alpha and A alpha. Now if we take A common here, we will get A 1 minus X by A. Okay. So here if we compare this value, we get alpha equals to X by A. Okay. Now alpha is X by A. Now if you see the equation, K T, okay, not KT. If we see that part, A minus X, what is the value of A? A equals to AT equals to A to the power minus KT. Okay, if we see this equation here, okay, here if we see ln A naught by AT equals to KT. Now here we will get here AT equals to A naught into the power minus KT. So AT is A minus X equals to A into the power minus KT. If we divide it by 1 minus X by A equals to E to the power minus KT. Okay. So alpha will be 1 minus E to the power minus KT. Okay. Now this will be the alpha with respect to 1. If we calculate the percentage of dissociation, then we will get percentage of alpha, then we will 1 minus E to the power minus KT into 100. So this value varies between 0 to 100. Okay. So that's how we will calculate the dissociation constant or degree of dissociation. Sorry, this will be a degree of dissociation. Alpha is the degree of dissociation. Dissociation constant is K. Okay, this is degree of dissociation. Now if we see the half time period, half time period we generally see which is half time period when T becomes to T half is when A naught by 2 equals to A T. Concentration of T becomes A naught by 2. Okay, so we know the formula K T equals to ln A naught by A T. Okay, now if we put the value of A T as A by A naught by 2, we will put K T equals to, then it will be T half ln A naught divided by A naught by 2. So we will see K T half equals to ln 2. So T half here comes out to be ln 2 by K. Okay, this is what independent of initial concentration. Okay, now we will see it is independent of initial concentration of A. Okay, so if we draw a curve between T half versus concentration of A, okay, it is a constant, it doesn't depend on A.